So we're very happy to have with us today Marc Boiron, who's the CEO of Polygon Labs. And he's going to be addressing a very interesting problem that we are facing today. You know, today we have so many protocols, we have so many chains, and we just heard in the morning that, you know, we would probably have 1,000 plus rollups and app chains in 2025. So this huge problem of fragmentation and so on, right? And Polygon is building something which is really cool and exciting called the Agglayer. But, you know, we have, obviously we have someone like Marc who's super qualified to talk about it. So for that, I'd like to welcome Marc Boiron. Give a round of applause, please. CEO of Polygon Labs. Hey, by the way, Marc was Chief Legal Officer at Polygon, and then he became CEO. So Marc, tell us, what is the transition like of a Chief Legal Officer to the CEO?
It feels very freeing to no longer need to just think about all the bad things that can happen, and you can actually think about good things.
Right. Thank you so much, Marc. The stage is all yours.
Awesome. Well, thank you. Appreciate Zeeve putting on this event. It looks like it's been awesome so far. So, all right, I am here to talk about the issues we have with just cross-chain transactions today. And one of the things that we're developing along with many other collaborators at Polygon Labs is the Agglayer. So before kind of getting into the Agglayer, I'm going to tell you everything that is currently wrong with Web3. And there's actually a lot that is currently wrong with Web3, unfortunately. So kind of some of the key things that we're looking at, right, is like, first we're talking about like the fragmentation being an issue. We've got scalability that is still an issue. We've got security that is an issue. And we've got a poor UX. Unfortunately, when you have all of these things that are not actually working well, you've got to kind of like analyze like what are you comparing things to? And what we're comparing things to is Web 2, right? And the reality is like we want Web 3 to eat up as much of Web 2 as possible. And so we need to solve these issues. So when we talk about fragmentation, like what are we talking about? Just a level set. First, we're talking about the fact that there's many chains that have many different assets. In many cases, these assets are wrapped assets. They're not even the same assets on all of these different chains. So as a user, when you want to interact from one chain to the other chain, you're literally talking about like assets that are like USDC dot something instead of just USDC. And you need to keep track of that, right? That is just not an okay experience, like whatsoever in any way whatsoever, for a normal person who's going to be like, I have 10 different versions of some stable coin in my wallet. Like that doesn't work out. Similarly, scaling. We look at like the scale of Web 2, and we talk about a blockchain being able to like handle payments around the world, or a on-chain exchange. And when you start like looking at these numbers, you start realizing that like this is not something that we are going to be doing on one chain. It's not possible, which makes that first problem, fragmentation, a guaranteed issue that we cannot solve by just putting everything on one chain. By the way, just very side interesting fact, I love it when people say that we're going to put like the NASDAQ on chain. I think that they can execute transactions with like a 50 microsecond latency. Forget like milliseconds, we're talking about like microseconds here. Good luck ever having that on a chain. You're not going to. And that's okay. Like Web3 is actually not the answer to every single problem in the world. It just needs to answer the problems that we actually do have. The next one is security. This is a picture of like what things look like today without kind of aggregation or the Agglayer, and what you get is tons of cross-chain transactions that are like from between insecure bridges or using intent, and like there is a massive lack of security in cross-chain transactions. And then you've got a UX issue, where you basically have like wallets that mostly don't solve the issues, but there are some awesome ones that soon will solve these issues for all of us. Shouting out specifically, why not, to Magic in the crowd over here, going to help solve that. You know, we got bridges and intents, and again, like it's all fragmented, works in different ways, high costs, that gets transferred onto users or subsidized, but can only be subsidized for so long. And then you've got like standalone chains that operate on their own, but really can't operate between them in any great way. And so really, when you like put this all together, you're like, okay, maybe we should find some solutions. So like the first solution that people try to sell everyone is that we can all just operate on monolithic chains. The thing is, they don't actually do that many transactions if you bring Visa and MasterCard into the picture, let alone NASDAQ. And so, no, like a monolithic chain is not the answer to bringing even one exchange or one payment system, let alone all of it, on-chain. Similarly, we've been sold on the modular thesis, that you just modularize everything and you take different pieces and then you're good to go. But when you kind of look at that, what you get is you start getting chains. Very proud of Polygon, but you know, still not actually good enough. You probably need all of this TPS to kind of come together in some way. And the way that you do that, when you've got limited performance, is by aggregating every chain. And the benefit of aggregating every chain and bringing them all together is that you get to unify three like important things. First is state, the second one is users, and the third one is liquidity. And I'll talk about this in kind of a little more depth. And so if we do this, what do we get? Two like important things. One, practically infinite block space. So when you say, hey, I need more block space because this blockchain can't handle every transaction in the world, then you spin up another chain and it takes on that added kind of block space that's needed. But then you really need to bring together one kind of unified bit of liquidity into like one piece. And so what does this really look like? And ultimately, it is bringing together all of this under the Agglayer. So I kind of like walk through real quick like what the Agglayer is, and rather than working through like a definition of kind of a neutral platform, I think I'll show you kind of like the key components. But I think when we talk about this, the thing you should keep in mind is that the Agglayer is not just a Polygon thing. It's actually specifically not called the Polygon Agglayer. Actually, the Agglayer repo is not in the Polygon repo. It's actually completely independent. And the reason for this is because Polygon is intended to unite all of Web3, not just Ethereum, all of Web3. And so what you're going to see is you will see chains from different stacks, OP stack, Orbit, as well as Polygon CDK, ZK stack. You will see all of them connecting to the Agglayer. You'll eventually see L1s in the Cosmos ecosystem connecting to the Agglayer. Across the board, we want to connect all of Web3, because as big as Ethereum is, and as amazing as Ethereum is, it is not all of Web3, and people will always choose to use other solutions, and they should be able to do it in a safe, low latency, cheap way. So that's really where the Agglayer comes in. It's really like 4 components to think about for the Agglayer. The first one is, we refer to this as a pessimistic proof. In fairness, we are kind of taking a little bit of shot at like optimistic rollups there by basically saying you should be pessimistic about every chain. You should assume that every chain is going to try to rug their users at some point. That's an assumption. I mean, this is the whole point of crypto, is that like you shouldn't need to trust anybody. And so you should also, when you're executing cross-chain transaction, assume that somebody is going to try to execute a transaction and use assets that they didn't actually have on a chain. And so the pessimistic proof is this concept of basically saying, we are going to look at every transaction that has ever entered a chain and every transaction that have ever exited a chain. And then when you want to do a cross-chain transaction, this proof is going to confirm that the assets that you actually want to send actually exist. And this is like the core security that is provided, and unlike existing bridges and other interoperability solutions today, it is actually trustless because of this ZK proof that is being used to create what we refer to as this pessimistic proof. The second one is that it lowers the cost. And so if you've heard Vitalik speak, and many others, you'll have heard that like ZK is the future, and that effectively what you should assume is every chain will have execution proofs on them in the future. So every chain will use ZK proofs. If you live in that world and you don't have aggregation, then what you have is every single chain submitting proofs to, let's say, Ethereum, again and again separately. That's actually very expensive. And so what we can do instead, and what is part of the Agglayer, is that we actually aggregate those proofs. So just imagine 3 different chains create proofs. You take those proofs, you wrap them together into another proof, and imagine 3 other chains created a proof and wrapped them together. You then take the wrapped one over here and the wrapped one over here. You wrap that together, and then you submit that to Ethereum, and the size of that proof doesn't matter. The cost that you put, the cost on Ethereum is basically going to be the same. And so you significantly reduce the cost of using execution proofs across the board, including the cost of the pessimistic proof itself. And it becomes super, super cheap to use execution proofs. And actually, very interesting side note. I don't love to do side notes, but I'm going to do a quick one here, which is people often say ZK rollups are more expensive than optimistic rollups. This is like actually fundamentally untrue. And the reason for this is because optimistic rollups have 7-day exit windows. Nobody wants to wait 7 days. So what do? You pay somebody a boatload of money to actually exit within like an hour or 2 hours, whatever it might be. We've looked at the cost of all of Arbitrum and how much it has cost people to use fast exits. And it is significantly, like multiples more expensive than if there was execution proofs on the chain. And so this tells you, because you can exit in an hour with execution proofs. And so this tells you that execution proofs are just fundamentally, literally cheaper than having fraud proofs. The third thing here is a unified bridge. We talked about this fragmented liquidity in these wrapped tokens. With one unified bridge, the assets can be transferred from one chain to the other, and you do not have wrapped assets. You have the same asset on every chain. And so when you are going to go to your wallet and you're going to say, I want to send one asset from chain, from Agglayer to, in the future, Newton chain, then what you're going to do is look at your wallet and the asset that you had on Agglayer is the exact same asset that you had on Newton. And that's the user experience you want. You shouldn't have to think about different assets. That doesn't really make any sense to have to think about different assets. And then lastly is fast interop. And so often people think of anytime you talk about interoperability as a bridge and nothing else. Think about the Agglayer as a bridge plus, right? A bridge plus security, a bridge plus fungible tokens, a bridge plus, in this case, fast interop. And so basically, one of the things that we're focused on is bringing sub 5-second, and I'm being very, very, very conservative here, cross-chain transactions in this secure way with fungible assets to all of Web3. And this is a side note. When I say all of Web3, how are you going to get that? We've been talking a lot about proofs and stuff. I should pause for 1 second and go back to this pessimistic proof. So in this pessimistic proof, we talked about the security that it enables. This pessimistic proof could prove anything. And so here's what I mean by that. You can take a chain that has execution proofs, like Polygon ZKVM or Agglayer, and you can prove the validity of that proof, and you can execute the transaction based off of that. You could also say instead, I want to prove consensus. So you could go to a Cosmos chain that has 100 validators. It can meet consensus, and then you can prove that consensus. And the second that consensus is satisfied, you now have a security guarantee when going cross-chain. Technically, you could literally just take a database on AWS and check all the transactions on that database and allow cross-chain transactions based off of that simply because you have a security guarantee. And that's how we get every single chain in Web3 to be able to connect to the Agglayer. Now let's talk about just a little bit of some of the practical benefits here. I've talked about the native tokens. I think that one's an important one. It's what makes kind of the UX actually good. Second one is safe cross-chain transactions. Again, we've talked about that one. Third one, compatibility. This is something that we haven't talked about. So a lot of people look at the Agglayer and they say, okay, this is nice and all, but I'm already working with a shared sequencer, or I'm working with intents. What does this give me that I can't already get? And by the way, they'll say those are actually better user experiences, for example, than what you can get with the Agglayer. These are all actually accurate statements, by the way. But the Agglayer is compatible with all of those things. So the Agglayer allows asynchronous transactions. So transactions that do not occur in the same block on Ethereum. The idea with something like shared sequencers is that you can actually have atomic transactions or synchronous transactions, transactions that are actually happening in the same block. So you want to like go ahead and like take a flash loan on Aave so that you can execute another transaction somewhere else. On another chain, you can actually do that with shared sequencers, and the Agglayer is built to be compatible with shared sequencers. Similarly, like intents. You want to use across to go from like one chain to another chain that's supported by the Agglayer, then you can go ahead and use across to do that. You don't need to use the Agglayer, but the Agglayer will add security to that transaction. On top of it, it's going to reduce the cost of that transaction. Because if you think of how intents work, what it is you have a solver on one chain that has a lot of capital, and you have a solver on another chain that has a lot of capital, and when you want to execute that cross-chain transaction, the capital is then used to transfer it to you. Problem with that being that now there is less capital on that chain in that token, and it needs to rebalance. Rebalancing results in two things: a potential cost in terms of the change in value, but also in terms of actually needing to hold a lot of capital. When you can rebalance in sub 5 seconds or hopefully less on the Agglayer, you can quickly rebalance with very little like risk, which means you need less capital and there's less like slippage risk, and that means that that intents and solvers can provide better pricing than they could otherwise, which benefits the users. Messaging. We think of like the Agglayer as like an asset-first protocol, but it also allows for messaging. This is kind of the opposite of what most bridges are. Layer 0 allows for messaging, and it transfers assets. This is actually focused on assets being transferred, which is the majority of what we actually do in Web3, but can also handle messages. Lastly, it allows for better chain abstraction. There's, for example, a kit that we built, which is called Bridge and Call, and this is a kit that allows for you to, for example, bridge from Ethereum in the same transaction. You can then buy an NFT over there, and then in the same transaction, you can actually execute it. Just one click, and it actually executes multiple call functions on different chains. And so it makes for, obviously, a much better user experience. Lastly, it's going to be extremely low latency. Given that I am mostly out of time, I think what I'm mostly going to finish with is that this is a bunch of the core contributors that we have. It needs to be updated because somebody did this about a week ago, but lots of great core contributors and even more. Bottom line, Agglayer is not run syncing. It's made for everybody, and that means that you can come connect to the Agglayer, not pay anything, and get all of these security guarantees, as well as low cost and low latency. So we've solved fragmentation, we have solved scalability, we've solved security, we've solved the UX challenges, and we're left with one beautiful Web3 that is synchronized and no longer fragmented. That's it. Thank you.